Hi, my name is Cassandra Champagne. I'm a PhD student here at the University of Michigan, and today we are going to be running the Direct Shear test. As always, we're going to make sure we have our safety glasses on before we begin anything. And the first thing that we are going to do is go over the equipment that's required for this test. I am going to be referencing the lab manual throughout this video, and I encourage you to follow along. The first piece of equipment we have is the shear box. So these two pieces here will assemble together to form the shear box. And then we have this loading cap. We have a funnel. We have a vibrating rod right here. We have the manual direct shear test machine. This is going to be the focus of our video using this machine today, but we're also going to show a demonstration later on using a more automated machine that you might encounter as well. Some additional materials that we're going to need today are a scale. We have our soil sample that we're going to be testing. We have a straight edge, a caliper, and a brush. Okay, so now we're ready to get started. The first thing that we're going to be doing is to prepare our specimen for testing. So we can turn to the procedure, and the first step is to record the inside diameter of the shear box. So we can see that the specimen is going to be circular, and so we're going to record this inside diameter here. To do this, we're going to use a caliper. So we're going to get out a caliper, turn it on, and then zero it out in the closed position. For inside diameter, we are going to be sure to use this side of our caliper. And then we'll just take a few measurements at different orientations to make sure we get the same value. And then we'll record that in our data sheet. Okay. All right. Okay. The next thing we need to do is to take the weight of our loading cap. So we can go over to our scale, zero it out, and we can record that weight also in our data sheet. Okay. Now we get to assemble the shear box. So this piece here is going to go on top of this piece here, like this. We want to be very careful to make sure that the inside of both the top and bottom portion line up perfectly. And then once it is, we are going to take these pins, and the pins are going to go right through these holes on opposite ends, which line up with the holes on the bottom as well. And they just screw in. This is just holding the top and bottom in place while we prepare the specimen, and then we will be removing the pins later on so that the top and bottom can move separately from one another. Make sure we have a nice flush surface on the inside before getting these nice and tight. Okay, that feels good to me. All right. The next step is going to be to actually place our soil specimen into this the shear box mold. And so to do that, we are going to be using a funnel. The first thing that we're going to do is put our soil sample into the funnel, and in a spiral motion, we're going to loosely deposit the soil sample into the shear box. For this test, we would normally be running tests in a loose state and in a dense state. So I'll show you how we create the loose specimen, but then we're going to densify so that way you can see both. And the test that we're going to run is going to be at the dense state, but you'll receive data for both. Okay, so let's start with our soil. We do want to overfill the shear box, and this is for a couple of reasons. We want to overfill so that when we densify and the soil basically compacts a little bit, we want to make sure that it's still over the top of this mold. That way we can use a straight edge and take off any excess and make sure that we have completely filled our shear box. So here we go again. I'm just going to slowly deposit the soil in the circular motion, not letting the soil fall very far, and this would represent the loose specimen. And we're going to overfill quite a bit. That's good. All right, I'm going to set this aside. I'm going to move some of this out of the way. Okay. So this would be a loose specimen. If we were moving forward with the loose test, I would then take my straight edge at this point and take off the top. But right now, I want to show how to make a dense sample. So that's where this vibration rod comes in. So basically there are 2 holes on this shear box, and we can pick either hole, and we're going to put the end of the vibrating rod into the hole, and then we're going to turn the vibration rod on, and then the soil is going to densify. Once it looks like the soil is no longer densifying, we'll take the rod out and we'll be ready to start our test. Okay, so hopefully you can see in the video a lot of the soil did densify into the mold, and then we also have some excess that fell off on the side. So next I'm just going to remove the vibrating rod from the shear box, and we're going to use the straight edge to get a nice even surface on the top. Okay, so now that our sample is densified, we're going to just take our straight edge and carefully as possible. This is a little bit difficult because there are some pieces sticking up. We're just going to clean up the top so we have a nice even surface. We also have a little brush to get things off the side. Some of these sand particles that like to hang around. And just keep doing this till we're satisfied. You always want to be very careful to keep each edge of the straight edge touching the mold as opposed to dipping down because we don't want to cut into the specimen. We just want to take the excess off the top. Okay, looks like we're almost good here. That looks pretty good to me. All right, now that we've finished preparing our dense specimen into the shear box, we are going to place the loading cap right on top of our specimen, and now we're ready to lower the shear box into our shear device. And it just sits right in there like that. It is a pretty snug fit. The next step is to take this hanger and place it on top of our specimen like this. And what this does, we're going to be applying weights to the bottom of this hanger, and then it is going to apply a normal load to the top of the specimen like this. This will be a constant load throughout each test. Next, I'll go over some of the gauges. We're going to be taking 3 readings throughout the duration of this test. The first one here is our vertical displacement gauge. So you can see as this probe moves, the reading changes. So this is going to be measuring displacement in this direction. Over here, we have our horizontal displacement gauge. So again, this has a probe over here that changes the reading. And this will be measuring the displacement as the shear box displaces in this direction like this. And then over here, we have our proving ring with the proving ring gauge. So this gauge measures displacement of the proving ring as load is applied and the ring is squeezed. And we have a correlation equation that will correlate this displacement reading into shear force. So now we're just about ready to get started, but one very important step that we need to take before we start is to remove these alignment pins on the shear box. We needed these to set up the specimen. However, it's very important that we allow the top of the shear box and the bottom of the shear box to move independently of one another. That way we have a shear surface for the test to take place on. So let's make sure everything is lined up, and then we are ready to get started. Okay, so now that we have our specimen in the device, there's just a couple last things that we need to take care of before we're ready to run the test. The first thing that we're going to do is apply weights to the bottom of this hanger. And this is going to, again, apply a constant normal load to the top of our specimen up here. So when we run this test, we are going to be running at a couple of different normal loads, but for the sake of this video, we are going to show you the 12 kilogram loading. So what we want to do is we want to take these weights, we want to just load them on to the hanger like this. That's 10 kilograms. Then we want to just set this one on perpendicular to the first one. And that's our 12 kilogram weight. We can just make sure everything is aligned, and we want to make sure that that's loading the specimen appropriately. The next step is to zero out all of our gauges. So we're just going to do so by turning the outside of the gauge till the needle is on 0. Like that. We got our vertical, our horizontal, and our proving ring gauge. Okay, those are all zeroed out. So the way this test is run is by cranking this crank here. We'll crank it in a clockwise direction in order to move this part of the device in this direction. When we do that, this will be moving the bottom of the shear box this way, while the top of the shear box remains in place. So that's going to create that shear surface for us. We're going to be cranking at a rate of 1 crank every 10 seconds to keep a constant displacement rate. And every revolution of the crank, we are going to be reading off the vertical displacement, horizontal displacement, and proving ring gauges. So there's a lot going on that has to be done simultaneously, so we're going to need at least one partner to come in and help us with this. And at this point, we're ready to start running the test. We're going to stop the test when the proving ring gets 5 consecutive readings in a row, indicating that we're at our residual shear stress. All right, so let's get started.
Let me know when you're ready to start.
I'm ready, whenever you are.
3, 2, 1, go. Now. 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 Now.
Okay. I have my 5 consecutive readings. Okay. Great. So that concludes the direct shear test.